Technically, a hallucination is when the AI generates a response that is factually incorrect. Most foundational models are trained on English-centric internet data. If a model can lie so convincingly, then what causes it to not create any kind of issue for other people? And today, we are just looking at what AI can do, but how we manage the cracks in the technology to build something truly useful. So welcome all of you to today's session on large language models in practice. And it's Aditya. I'm founder of CreateBytes, CBX. My background with YugYog.ai has focused on the architecture required to make AI work reliably in production environments. And today, we are just looking at what AI can do, but how we manage the cracks in the technology to build something truly useful. And that's what we are going to be doing today. And the overall slide, which is basically LLMs in practice, this title of our talk is something which is moving beyond the magic phase of AI and into the engineering phase. Our goal is to understand how to move a model from a playground environment into a stable customer-facing product. And you know why this matters. Why is this technical understanding critical for us? Because while AI models appear intelligent, they are not perfect. In a production settings, they can confidently provide wrong answers, known as hallucinations, or amplify existing human biases regarding gender or race. To build responsibly, we must understand why these failure models happen at the end, and more importantly, how to architect systems to reduce them. And that brings up to a very important concept, and which is what is hallucination. Technically, a hallucination is when the AI generates a response that is factually incorrect. But syntactically, it sounds and it feels like it's correct and very highly confident. We generally categorize these into three different forms, and we need to understand these three. Hallucination type 1 is like fabrication. The model invents entirely new entities, like fake legal citations or scientific studies. That is fabrication. And this is something which we all talk a lot and discuss about it. We have seen an example of Deloitte doing this. There is another which is distortion. It mixes legitimate facts with incorrect details, making the error harder to detect. And the third one of hallucination form is overgeneralization. It assumes a universal pattern based on limited or non-existent data points. Again, we need to understand this, and this is very, very important and critical. Fabrication, distortion, and overgeneralization are three different forms of hallucination. Fabrication, where the model is just inventing something entirely new. Distortion, it mixes legitimate facts with incorrect details. And overgeneralization, assuming a universal pattern based on limited or non-existing data points. But the question is, why do these hallucinations happen? What is the reason for these? What exactly cause these? And to understand this, we have to look at the training objective. LLMs are trained on massive data sets that include opinions and fiction, both of them together in a very, very factual scenario. Generally, the model's fundamental job is to predict the most likely next word based on patterns and not to verify the truth. And this is something which is important. The fundamental job of these large language models is to predict the most likely next word based on some patterns. And the fundamental job is not to verify the truth. That simple thing explains the reason, the base reason for it, because that's the objective for which they have been trained. It lacks a built-in fact checker. It learns the shape of information, but not necessarily the underlying reality of it. And that is important. And this brings up to a very interesting question, and I want to understand it from you. We have got an idea about like a very basic level that there is something which is called as hallucination in large language models. And since we know the model is just predicting the next word, most likely what is going to be the next word which is going to come out from the pattern, what kind of prompt do you think a model is likely to force a model to hallucinate? Let's say, what are you going to write so that you know for sure that model will hallucinate. Is it a question about a very famous person or a question about a niche topic that doesn't exist? And a question is to you. And again, I'll ask the question, what is a prompt which you can give to force a model to hallucinate? Is it related to a famous person or a question about niche topic? And would love to know your answer for this. Like, if you guys can give your answer, and I'm gonna check it. Okay. So the simple question for you guys is, what is the mechanism in which one can say that there is basically a prompt which I can give, which can actually like force a model to hallucinate? Okay. I can see on the other chat there are answers, but let me try to give you a very interesting scenario here. LLMs learn patterns and not truth, that we just like got through high level idea. What happens is, like, there are two kind of data sets: high density data sets and low density data sets. This is from the training purpose. For a famous person, the model has seen that like this particular famous person millions of times. Maybe let's say a famous celebrity. So the statistical probability for the next word is very narrow and stable. But for a niche or non-existent topic, the training data doesn't have the answer. But we need to remember the model's fundamental job is to predict the most likely next word. And if the density is low, it literally creates a scenario where it may not be able to give you the right next word. But it is not the scenario where it's gonna say no, it is gonna give you something. And that is the place where it can fabricate. So it uses the pattern it knows from similar sounding topics to fabricate a response. And it sounds confident and realistic because the grammar and structure are correct. And this is something where a lot of times we tend to even, let's say, ignore it because of the confidence in which the answer comes in and the grammar with which it is used. And this causes the facts to get invented, which may not even be present. So it's like filling in the blanks with probability rather than reality. A very, very basic concept. Okay, now we're going to touch a very interesting use case. And this use case is like a very famous case study. And I'm going to explain it, keeping in mind that maybe all of you may not have heard about this, which is called as Dolly case study. So let's take this example as what happens when models' world knowledge hits a dead end. In 2023, and it is like January, February, March, that month duration, users asked GPT 3.5, does Databricks Dolly contribute value to the open source community? Databricks is a company, and there was a model Dolly. And now for us, this is a question about a specific AI model. And the interesting part is it is asked to GPT 3.5, which had technically a training gap in its own data because it stopped training in the early 2022 when it got released. So its knowledge was frozen in early 2022 and Dolly 2.0 didn't exist until April 2023. Because the model has no ground truth for this query, it faced a choice. Either it admits that it doesn't know or it just guesses. So instead of stopping, the model performed what we call it as out of distribution reasoning, OOD. Now this is interesting. It calculates that Databricks plus new product likely equals to a data migration tool, because that's what Databricks does. And it didn't lie in the human sense. It simply followed the strongest statistical pattern it could find in let's say in a very confident manner. And what it did, it gives us an essence of a hallucination, and the model prioritized the pattern over the truth in this example and in this case study, which is very, very interesting to understand. And this case study, when it happened, it opened up a lot of literature review papers around it, and then how different things can happen. But this is important to understand. But important question, and I think there's famous news of Deloitte where, if I'm not wrong, around $300 million, there was something with Australian government where they had to refund or something. So there is a very interesting fact that hallucinations are dangerous, but why they are dangerous? If a model can lie so convincingly, then what causes it to not basically create any kind of issue for other people? And the problem is that because these LLMs, they possess superficial fluency. As I mentioned earlier, the grammar is quite good. they look like statistically right. So it basically creates a kind of a smart human which naturally lower their critical thinking scenarios. So when I'm going to read this, I'll think that, oh, fine, this looks good. Maybe it is correct. From a security perspective, there's a statistics. 49% of industry leaders believe that these models will accelerate misinformation attacks, which are very common and which can happen. Technically, we are looking at the potential for automated propaganda and fake research citations because a lot of people have started depending on large language models to even draft some of their papers. And it is difficult for someone to review, and a lot of times, if let's say mistakes are going to happen, they're going to be bypassed. And it is not a bug. We need to understand. It's a systematic risk to social trust and economic decision making because the model can generate high entropy. And this causes false information that is very likely indistinguishable from the reality. And that is why the hallucination is dangerous. Now the question is, if we understand what is hallucination and we know that it is dangerous, is there a way to mitigate these things? Is there a way where we can reduce it? And now, like, that basically came up with a lot of different strategies. So how do we fix a model that is designed to guess? So we move from generative to constrained architectures in large language models. What we can do, we can tune generation parameters like temperature, which I'll explain later on, to limit the model's creativity. We can use careful prompting to create logical boundaries. The most powerful solution is RAG, which is Retrieval-Augmented Generation, which is present there. Logic, instead of asking the model to use its memory, we give it a book like documents and tell it only answer from this book and nothing else. That is basically there. And we are going to jump into the details about like what are these and how these perform. Now, there is a concept when let's take a large language model, and when this large language model generates text, it doesn't just know the next word. It calculates a giant list of probabilities for every possible word in its vocabulary. If we don't control this, the model can either be repetitive or completely nonsensical. We use four main, let's say, you can consider these like the benchmarks or let's say the pillars or the knobs to shape the probability curve. And this is important, and this basically is going to also create a base for other slides. And I'll start with the number one thing. And this is something which is like, I won't call it very technical, but are fundamental aspects. Number one, temperature. This is like a probability. Think of temperature as a tool that changes the sharpness of the model's choices. At low temperatures, let's say from 0.1 to 0.3, we exaggerate the differences. The most likely word becomes almost certain, and everything else which is present there, it just drops to zero. This is like a kind of a banker mode where what we say is, if we are trying to predict and it is very highly likely there, then it is safe. And then let's proceed. The other one is where we have high temperatures, let's say above 0.8. And I'll explain it again, this concept, because we'll be touching this in a lot of different scenarios. What we do at high temperatures, we try to flatten the curve. The gap between the number one word and let's say the 100th word, it shrinks, making some kind of, let's say, very, very surprising choices. Because now what you have done, the 100th word, which is less likely, is coming close to the first word. Why this is needed? In some scenarios where there are more creativity involved, there you do not try to say that this is the best and this is the least. And this happens in a lot of models. And I'll give an example of, let's say you have a model for poetry. In those scenarios, you would rather want a high temperature. So again, when you keep something as a low temperature, what you're trying to do, you're trying to say that, okay, fine, I'll only consider the top. So 0.1 to 0.3 I've taken, it's like at the top. But when I increase the temperature, I'm trying to create a highly likely chance for other words to come in the same domain, which is like, let's say, first word and 100th word, both of them can be predictable and the gap between them gets narrower. And this is something which is very common when we are trying to use LLMs in creative angle. So when you see these models, these GPT and all, and you see different modes. They're trying to do different parameter changes, different thinking patterns and all. These are all these examples of variations which they do. The other thing which is basically very interesting is the top P, which is nucleus sampling. It's like a dynamic cutoff. Instead of picking a fixed number of words, top P looks at the cumulative probability. If we set P to 0.9, the model adds up the most likely words until their total probability reaches 90%. Again, try to understand. Let's say if I set it to 0.9, what it does, it adds up all the likely words till the time the probability reaches the 90%. That means, let's say the tail of the last set of the distribution, which is, let's say, the 10% of the words, these become complete nonsense, are not at all needed, and so it chops off those. So what it does, it basically tries to align that the model stays within a certain radius or nucleus of sensible options and does not take those options which may not be even needed. Again, a scenario which can be used for a lot of purposes. So what you're trying to do is create a kind of a radius that only these kind of things I'm going to take, others I'm going to completely remove. The third one is again a very interesting thing which we think about, which is like frequency and, let's say, presence penalties which are present. So these are like repetition guards. These are mathematical taxes which we place on tokens. Again, these two things I'm combining together, and you need to understand it from the last two in a perspective where how these are being used. And the single word for both of them is like the repetition guard. What is a frequency penalty? Every time the model uses a word, like let's say the or awesome, it becomes slightly more expensive to use it again. So this is called as a frequency penalty. What is a presence penalty? This is like a one-time tax on that. Once a word is mentioned, the model is pushed to explore new words and topics rather than looping back to what it already said. Now again, these are very important. For example, if I use something there and I know that I need to create and generate new innovative ideas, I'll put a presence penalty to it so that it gives me 3 points. And point number 1 is not similar to point number 2. So that is why the other two parameters, frequency penalty and presence penalty, become important. Now I'm going to give you a scenario. Okay, and you guys can just raise your hand and say yes or no in that. What we saw that GPT 3.5 hallucinated because it's like it has a kind of a world knowledge, and in 2022 it stopped learning, and then from there we asked a question which was of 2023. If I ask a model today about news event that happened yesterday, try to understand the question. If I ask a model today about a news event that just happened yesterday, do you think that if we adjust the temperature, will it stop or reduce the hallucination of the answer? Yes or no? I'll explain why, but just answer yes or no to me. So when you say yes, just raise the hand. That's it. If I change, okay. Ankush is saying that if I change the temperature, it can reduce hallucination. Kripa is saying okay. Okay. Again, I'll try to repeat the question again. The question is, if let's say that we have a news which has come yesterday and I ask the model about the news today, and if I adjust the temperature, is the model going to respond back in a hallucinated manner or not? Yes or no? So Ankush and Kripa saying yes. And then, okay. So the simple answer for that, and try to understand, is, okay, the others have not answered and I'm assuming that they have some confusion, but the simple answer is no. Temperatures, like even if we adjust temperature, they will not stop the hallucination. Temperature is a mathematical, let's say, a kind of a, like your kind of a gas norm. Like what it does, it changes how we sample from model's existing probability distribution. It doesn't change what the model actually knows. If the model has not seen it, then it doesn't have any kind of statistical probability to answer from that. So your low data density can even, like temperature can help in that scenario. But if your news was of yesterday, the model has not seen it. So even if you change the temperature, it basically will not be able to reduce or even remove or does anything with the hallucination. To give to elaborate more, assume that the model will give you a kind of a hallucination if you have a 0.1 scenario. But if you increase the temperature, the model will give you more creative hallucination. That is it. Hallucination is going to be there, it is not going to change. It's just like with 0.1, it may have some boring hallucination. Let's say it is going to take some words and some outdated pattern, it's going to check and maybe give you something. But if you increase the temperature, it may just be creative in terms of hallucinating. That is it. But in both the scenarios, it's going to hallucinate. So this is important to understand. And now, and then we'll come back to it with another question on it, and I'm going to jump back there. But to give a more detailed understanding, try to understand these external documents, how can they help? Because now the question which I asked is something which is related to this. So now if hallucinations are caused by a model guessing from its internal weights, the solution for us to basically go in those scenarios is to somehow figure out a way that we are giving kind of an open book exam, where instead of relying on the parametric memory and the weights of the model, the information is backed by something which is basically non-parametric and through some supporting documents. So let's say when a user asks a query, we don't send it straight to the large language model. First, we convert that query into vectors and embeddings, which is like, let's say, a high dimensional neural representation, a kind of numerical way of defining it. Then you have some kind of concept which is called a semantic search. We then search a document database for the most similar content. And then finally, we do context injection, which is the top matching text chunks are retrieved and provided to the LLM as a factual scenario. And this is again the concept of retriever architecture, which brings us to a very important concept, which is what is RAG. And again, I'm assuming that most of you understand it to a certain extent. This is basically a framework that shifts the large language model for relying purely on its internal memory to acting as a smart researcher. You can think of it as like a two-step pipeline. Number first, it searches and then it synthesizes or generates. You have factual grounding in it. So by injecting external data into the prompt, what we do is we ground the generation in kind of core topics which are present there, which are not out of reality or let's say out of the context. It is giving a scenario where you know that from this is the place you need to extract the outcome. Then you have a concept where a lot of engineering advantages can be extracted from it. Like for example, you can have updates whenever you want to. Yesterday's news can be added there so that now you can extract it. So these are some things which can happen in real time and can improve it. And again, because the model is based out of references and source of truth, the likelihood, and again, hallucination is of different types. So we need to understand we are like likelihood of fabrication kind of hallucination will not be present. And it will be reduced, drastically reduced. But there are other hallucinations too, which may happen, which we discussed. So fabrication kind of hallucination may be reduced to a very large extent with this. And this is important to understand. And this basically brings up to another interesting concept with these large language models. Because now what we have seen that like large language models can somehow be factually grounded with, let's say, some sort of data which is present in the documents. There is another problem which basically is present apart from the factual grounding of data, which is biasness. So a bias occurs when a model's output is skewed in a manner where one group is favored more as compared to the other one. Think of it as, let's say, a mathematical mirror of internet. So whatever is present of internet, the mathematical scenario is present in that LLM. It doesn't have its own opinion. It simply reflects the statistical probability of the text it was trained on. That's it. And if that training data contain some kind of stereotypes, for example, let's say frequently mentioning men as CEOs, or let's say frequently mentioning women in fashion, the model will calculate that these are the correct patterns which I should be following. This isn't just about being polite, in a kind of a production app, but this is basically going in a direction where in a very natural mechanism, you're saying that, okay, fine, this is what the data is, the pattern shows me this, I'm gonna say this. But this a lot of times create some kind of harmful narratives, which we've seen in some of the models which came out from Grok and Google Gemini too, and also it creates stereotyping in some way or the other. But this is something which happens with large language models when they are being trained on. But the question is, like, the biasness is coming from where? Like, where exactly it picks up? Because, for example, you have data set and there are different things which are present. So the default, the basic scenario is if large language model is basically mirroring what the internet contain, then there are basically directly raw data which is coming up, which creates the foundation of this particular biasness. And a lot of times this concept, there are studies around it. These are called as the data ecology, where this is being discussed. So you have some kind of human filter, you have some kind of structural choice. Why? Because number one, biasness comes from the raw data, but that is not it. You also create biasness because of the mechanism in which you annotate on top of it. Let's say after doing some pre-training, we use some humans to label the data or rank answers that make the AI, let's say, much more niche, insightful and others. But that also has some kind of human filter which can cause biasness. So biasness is not just about, for LLMs, it's like you just put the raw data and then start doing the pre-training, but also comes with the annotation scenario. The other interesting thing which comes up is the design layer, which is how you create the architecture. What are your structural choices? The choices which the engineers make at the time of like designing the model. Let's say they can say which language they want to prioritize. They take English, for example, or some Western-centric languages, let's say Spanish. So these three layers in a very interesting scenario create biasness. And the three layers are like the raw data, which is present there, the annotation mechanism, or you can call it as the human involved, or sometimes even the bots are involved there, and then the way the design has been created, which creates it. Now, there's an interesting thing which relates to this to a very large extent. How do we scale AI safely when model generates millions of words in a minute? Okay, and before I jump here, we need to understand one more important concept. Like the constitutional AI is also having a very much correlation with what we just discussed above, which is the mechanism in which the biasness happens. Because when you scale also, that is going to just grow. So then what is the mechanism? So let's say we cannot just hire a lot of humans to check everything. So Anthropic had a solution, and this is very famous, and they call it CAI, which is called as constitutional AI. It's a method that replaces manual human labels with a principled automated feedback loop. And this is very, very important and being used at a very large extent. So what happens? You have a constitution, which is like a rule book. So we start by providing a constitution, a clear set of natural language principles. Like choose the response that is most helpful, which is most honest, avoid any kind of harmful stereotypes. These acts as models' objective functions for behavior. Then we jump towards a self-critique and revision scenario, where we go in a very supervised stage. The model is shown toxic prompts and generates a response around it. It then uses its constitution to critique it, to see that the response which have come, what is the critical nature. This answer is helpful but potentially biased. Finally, it revises its own text to fix the error. And we then fine tune the model on these perfected versions which are present there. And then we jump on to the next layer, which is called as the alignment stage. And the important thing is reinforced learning from AI feedback, RLAIF. This is like a core technical innovation which came up with CAI. The model compares two different answers to the same prompt and chooses the winner based on its constitution. This choice trains a preference model which then guides the final AI to say that it is a safe answer and it is unbiased. in a very automatic direction. We get some kind of AI that isn't just following a filter, it has internalized the reasoning behind the safety, making it less evasive, more transparent, and less biased. And this is again a very important concept, which is at the production level when you call at B2C scale how these internal sides work. And I'm going to explain it again at a very high level so we remember it for sure. It's called as CAI, which is constitutional AI. What we should remember, number one, the first layer, the constitution. We say that this is your rule book, a clear set of natural language principles. Choose the response that is most helpful, honest, without any stereotype, biasness, and all. The constitution, the rule book. The second one is called as the self-critique and revision, kind of a supervised stage. And the third one is the alignment, which is reinforced learning from AI feedback. And this is the third one, where what is happening, the model compared two different answers, and then they say that the same prompt chooses the winner based on its constitution and rulebook. And these three things create CAI for us. Now, with this, we come back to a very interesting topic, which is training versus evaluation. When we say that, okay, my model is safe, it is giving me answers, how do we evaluate that? And then, for example, how are the trainings happening here? So how do we know if our AI is actually getting smarter? Do we have to look at two different worlds where we see that whether training is doing it, or then after that we evaluate, what do we do? So it's like a kind of a signal where during the training, the model lives in kind of, you can call it as a mathematical vacuum where its only goal and nothing else is to minimize its loss function. Loss is like a penalty score. Every time the model predicts the wrong next word, the loss goes up. The model uses a process called as gradient descent to adjust its internal weights, trying to make the loss number as small as possible. It's like, let's say when we are playing a game, the only thing which I need to make sure is that I do not miss the shot, because I just need to make sure that either I am touching the ball, taking a single run, or like just doing something around it. So it's like what you're trying to do is figuring out a way where you can keep the loss minimum. And this is something which happens in training, and that is why I call this specifically mathematical vacuum. That during the training, the model lives in a mathematical vacuum. Now, what happens after that? The evaluation matrix comes later on, which is like the final grade. So once training is over, we stop looking at the loss function, because from a human perspective, they don't care about some decimal point penalty function and all. And what we care about is what is the utility of it. And that is why the utility is defined from the perspective of humans. And so we basically have these matrices like accuracy calculation, F1 scores. So these measures are kind of real world performance. Accuracy tells us how often it was right, while the F1 score, it basically does something which is like when it is not giving me the wrong answers, it balances precision. So there are two aspects. We have F1 score, we have precision, we have recall value. Okay, let's try to understand what is a precision. And we have heard about, or I'm not sure whether you guys have known it, but it's like very common terminology. Precision is when it is not giving the wrong answers. Very simple. Recall is when it is not missing the right answers. Very simple. Okay. Now, once I know the evaluation, and we'll get into the evaluation matrix in more detail, but for the timing, let's just try to understand the bigger picture. What is the objective, where it is just trying to calculate the loss function at the time of training. Then it does the evaluation with these. It is more of like a utility for humans, so they calculate it in a different mechanism and not look at the penalty score, which was the loss function. And then comes the intrinsic versus intrinsic scenario. Meaning, we categorize these matrices into two concepts. Intrinsic matrix, and it is important. These matrices, the model's internal language quality. One important aspect is called as perplexity. It is very famous. What it does, and it is not perplexity AI. This is basically an intrinsic matrix called as perplexity. It technically measures how confused the model is when predicting the next word. Lower perplexity means the model is more confident and fluent. So what is the objective? We need to ensure that the model is lower perplexity so that the confidence is higher. And what is an extrinsic matrix? And this is used quite widely. These measures the model's performance on actual task. So we use benchmarks like GLUE, General Language Understanding Evaluation, very famous, to see how it handles logic, grammar, and sentiment in real world scenarios. Again, let's try to distinguish these two. When I call intrinsic matrix, it measures the model's internal language quality, like technically measuring how confused the model is when predicting the next word. So it's like an intrinsic parameter and matrix for it. But when we are talking extrinsic and GLUE, which is general language understanding evaluation, it checks how the model has handled the logic, the grammar, the sentimentals in real life when it gives the response. And this is important to understand. And now this brings us with a question with respect to the concept which we just discovered. And I have, like, one of the very interesting thing for me is to see how you guys are able to distinguish in terms of parameters as well as the scenarios in which we use RAG, and or also let's say how to reduce biasness. So in the same context, assume that you have some BioBERT, or let's say a medical LLM. BioBERT is it's a transformer model, but let's take an example of a large language model, let's say a medical large language model. So we have two choices and try to understand this question. Number one, I fine tune the model. And do you remember fine tuning and training? We just discussed training as three things: loss function checking, then the scores which we just talked about, and then intrinsic, extrinsic parameter, and all these things come in. So we fine tune the model on, let's say, some 10,000 medical textbook records, versus I build a RAG system where the model can search through 10,000 books in real time. And my question to you, and you just need to say yes or no: if a new medical discovery is made tomorrow, let's say tomorrow a new thing has come up, which approach is going to be better? Should I add this data set in my fine tuning, or should I add it in my RAG? Which will allow me to get a correct or a better answer? You understood the question? Let's say I have a medical data set, I have 10,000 documents, I fine tuned those with a one large language medical model, and the other one, what I've done is basically created a RAG from it, from where I can retrieve it. Now, if I've given an option that tomorrow there is a new research which has happened, should I fine tune it and put it in the large language model for medical training and make it better, or should I use a RAG system? Those who say that fine tune is better, raise your hand. You understood the question. So which one is going to be better in terms of utilizing it? Okay, a lot of you guys are raising hands. Okay, let me explain. And this is important. Again, what we need to understand is that out of these two, RAG is always the right approach when I have to add some new, let's say, research which has happened. This is for providing an answer, let's say, from the perspective of tomorrow, day after, a new thing has come up. RAG works by searching external docs, database in real time, and so what you do, you just add it in the knowledge base. There is a bottleneck if you try to fine tune. Fine tuning requires retraining the model's internal weights. It's like creating again a computationally intensive process that can take days or weeks on the GPU, and then it is not necessary that the models are gonna respond back in the right direction after doing that fine tuning. So fine tuning creates a kind of a frozen snapshot of your knowledge till the time you've done it. RAG allows you in a more dynamic fashion keep on adding more documents and then retrieve the data from there. Both of them have their own use cases and scenarios, but in this specific example, RAG would have been a better option for us. Now, let's jump on to a very powerful thing which we discussed, which is perplexity. To understand this in a more detailed fashion, you need to think from the perspective of that the model is actually learning, or is it just guessing widely using some random scenarios? So the perplexity, as I mentioned earlier, is a measure of how well a probability model predicts a sample. If a model is perplexed, it means it is confused by the next word. Overall, what we can see that we look for a lower perplexity. A lower score means the model assigns high probabilities to the actual words in the text, and it indicates that it has captured the underlying patterns of the language efficiency. It is the difference between a student who knows the answer versus who is basically just randomly guessing. Very simple. So anyone who is saying what is perplexity, if I have a lower perplexity, I'm less confused, I'm not likely to randomly guess something. And now this introduces some important benchmarks for us. And again, whenever we are working with large language models, when you use a new model, you should always look for benchmarks. You would have seen a leaderboard is present, a lot of models are comparing each other. We are going to discuss three important concepts. So let's say GPT 4.5 has come and 5 is getting released, and these models are coming out. So how do we prove that which model is smarter? Sorry, whether it's Claude is smarter or Llama is smarter, how do we prove that? So we create some standardized benchmarks, which are like, let's say when you give an exam, you create a score, and then that score tells you that you're good in maths, you're good in physics, you may not be good in English. In a similar fashion, these benchmarks for large language models are created. And glue and super glue, which are basically very famous, these were the original standards in the beginning, and they were being tested for testing very basic natural language understanding, like sentiment analysis and whether two sentences mean the same thing or not. Super glue, which is an upgrade on that, it basically introduced harder tasks like common sense reasoning and co-reference resolution. Co-reference resolution is something which is a very interesting concept. It figures out, let's say, who he refers. Let's take an example. Let's take a random example. If let's say I say Aditya does XYZ, he is doing this because. So now co-reference resolution can figure out that we are talking about Aditya. That's there. So it's like what's happening here. Super glue has upgraded the general glue capability, which was used for natural language understanding to figure out whether two things are similar, to the level where it tries to figure out common sense reasoning. And one example is co-reference resolution. It understands the mechanics of a language to a certain extent. So glue and super glue are these two. Then we have Big Bench and Helm. These are like comprehensive exams. What is Big Bench? Beyond the imitation game, the full form, Big Bench. It is a massive collaborative effort with over 200 tasks. It tests everything from logical detection to whether an AI can understand a joke or write a code. Everything. That is Big Bench, and that is why the big benchmark. And it's like a very famous one. The other one is HELM, Holistic Evolution of Language Models. It is the most critical modern framework right now. It doesn't just look at accuracy, it measures multiple dimensions, including fairness, biasness, toxicity, and even how much energy the model uses, which we call as efficiency. And it is important. Again, so we have Big Bench and Helm. The third one, which is again like quite famous and present there, is called as Flask. It is called as the Fine Grained Skill Report. Most benchmarks give a single score, but Flask breaks it down into 12 specific alignment skills. And it's like a very good standard. It tells us exactly where a model fails, it is lacking logical correctness, or if it is lacking factually incorrect or correct scenarios, or if it is failing around user alignment, whether it is being helpful for the user or not. So this allows the developers to fine tune specific weaknesses rather than just guessing and randomly fine tuning it to give a better response. So Flask is being used a lot by engineers to figure out a way to improve the models. So we had glue and super glue, we had Big Bench and Helm, and then we had Flask. So these are some of the popular benchmarks which are present there for us. Now, these are very interesting things which comes in a concept called as decoding methods. How does a model turn a list of numbers into a coherent sentence? You understood? We discussed in our very first webinar that there is a transformer. And in that, we have encoders and decoders. Now, how does a model from those mathematical numerical numbers figure out a coherent sentence? It uses a concept of decoding strategy. The logic is to pick what is the winning word from the probability list of words. And now there are different ways to do it. The greedy search method. This is like the path of least resistance. This is simplest, like very basic one. The model looks at the list and always picks up the single most probable word. It is like very easy to understand. At the same time, it is computationally fast and very highly efficient because I just need to pick up the best one. The problem with greedy is it doesn't look further beyond the next word, and which often creates a scenario of repetitive robotic loops because the model gets stuck in a cycle of highly probability. But let's say I know that this word is highly probable, I'm going to use it, and maybe again I'm going to be using it. So it creates some sort of repetitive scenario. That is the downside of it. It's simple, but there are issues with it. The other one, which is basically again quite common, is the strategic planner, which we call as the beam search. So instead of just picking the one word and moving on, beam search explores multiple candidate sentences at the same time. We need to understand this. So it has gone a way above than the greedy search method. What is the logic? It keeps track of the top. Let's say you have a beam bit. So it keeps track of all the top next words, most likely sequences of all the scenarios for multiple candidate sentences. And then it eventually picks up the sequence that has the highest overall probability. It produces, and because of this, what you get is much more coherent and structurally sound text than what you could have got in a greedy search scenario. So again, beam search is instead of picking up one word and moving on, it explores multiple candidate sentences at the same time. Now there is another concept which is sampling. It's like sampling introduces some kind of randomness for picking words based on their probability. Now the question is, how can this benefit? Like beam search, we can understand. It's like a strategical scenario where I know that I'm keeping track, like a track of multiple candidate sentences, and then I check for the beam bit, which is like, let's say, the top B of those sequences, and then finally figure out the overall probability. So it's strategic, I can understand. But why sampling where it is picking the words randomly based on their probabilities? The benefit is it allows for some kind of human-like creativity and some kind of variety while picking it up, and not just some automation robotic scenario of strategic planning. The risk with this is if the randomness is too high, the model may pick up very low probability word, which make it very incoherent, and let's say maybe some kind of not even needed scenarios and words which have been picked up for the sentences. So there is a benefit, but the risk is there. So you can mitigate it, but it's important that the randomness need to be at a lower end so that while sampling is being applied, it is basically picking up some sort of at least, let's say, nearby words which can be picked up. So again, greedy search, beam search, and sampling are three ways to decode from the numerical terms which are present to a most likely winning probability for a word. And again, this is important to understand. Now, we're going to jump to a very interesting concept which is called as top K and top P sampling. Again, pure sampling, which we just discussed last time, it's like throwing some random, let's say you throw a ball where you have different circles and then thinking that, okay, fine, out of these 50,000 words, it's going to just choose something else. It's very chaotic and it creates much more randomness and, let's say, erroneous scenarios for us. To fix this, there are techniques which are being used, which are called as top K and top P techniques. So there is a top K sampling. It's like a static filter. What we do, we tell the model to rank its vocabulary by probability, and then throw away everything except the top 10, top 5, top 100 most likely words. Very simple. So let's say if out of 50,000 words, we put k equal to 50, the model only chooses from those 50 words. This effectively kills anything which is like out of those 50, and like a long list of things have been removed. It ensures that the output stays sensible while it is still allowing some randomness, like which is human-like characteristic involved. Then there is top P sampling. It's a concept of dynamic filtering. And if you guys remember, a dynamic filtering concept was applied earlier too. Some kind of radius which we created, you remember, which we called nucleus sampling. This is a little, let's say, better, but what it does, instead of a fixed number of words, we set a probability threshold, let's say probability of 90%. The model adds up the most likely words until that total probability reaches beyond a certain mark. And this is a better approach. So this is dynamic. If the model is very sure, like let's say after the New York, it knows that which is the next word. Generally, the candidate word can be city. So in those scenarios, it is going to pick those up. So it allows for creativity because of the randomness, but also ensures that you have certain range of probability in which you can answer. So we have top K, which is like static, you have a number, top P, which is like you have a probability to decide that. That is the top K and top P mechanism. Now, while you are doing this, you can also have more control with temperature and penalties on it. Now, beyond filtering, we have some kind of, and I call these as environmental controls, because they change how the model perceives its own probabilities. Okay, so let's give an example. Temperature. Technically, temperature scales the entire probability distribution before we sample from it. Let's say I have 0.1 to 0.3. This sharpens the peaks, meaning that it is only going to take the top level. So the most likely word become the, think about it. This is a concept which you can even think in image analysis when you are doing histogram equalization, or you are trying to get the best intensity pixels and remove anything and everything which is not there. So, so what is happening? High temperature is like histogram equalization, I think. The lower one are like you just pick up the most highly intensive outcome and then say everything is 256 if you have higher intensity. So the mechanism is, and let's try to understand what we are doing. The most likely word become much more likely, and it often basically creates a scenario where all the other words are dropped off. So model become deterministic, focused, and there can be fewer mistakes with this. And this is perfect for anything which is highly technical, or any model which is driven and built to give you factual tasks and outcomes. We need to understand when to lower the temperature, when to keep the temperature higher. So when I have a large language model where I have a very highly technical outcome, or there are factual sides, I keep the temperature lower, which makes it deterministic, focused, less mistakes. But when the temperature is, let's say, 0.8 or plus, it's like, and I'm almost correct, it's like histogram equalization where it flattens. So what it does, the gap between the top word and the lowest word, it gets reduced to a certain extent. And that basically give a space to outcome and results from large language models which need some creative nature to it, some kind of surprising angle around it, but it also increases the risk of hallucination. But a lot of times, let's say story building activities, you need fabrication. You need some random scenarios. So in those scenarios, it can be good. Now, the other thing which we discussed, which was penalties, which again, we talked about it. Frequency penalty, presence penalty, the repetitive guardrails which are being put in. So if, let's say, any kind of word which is coming again and again, so it technically punishes the tokens based on how many times they've already appeared in the text. It prevents the model from getting stuck in a loop of the same phrase again and again and again. So frequency penalty plays a very important role. And the other one, which is presence penalty, plays an equally important role. It punishes a token just for existing once in the text. And the goal is to encourage the model to introduce entirely new words and ideas. Where it is good at, when you want to have long form answers which have much more diversity, then what you do, you have a presence penalty so that those are not being repeated or let's say issues come in. This brings up to a very interesting question. And again, assume that you are building a chatbot and this chatbot is for a bank to explain interest rates, and you build another chatbot. This is for poets to write, let's say, songs, or this is for writers to write stories, or a script writer to write a movie story. So you have one chatbot which is for banks to explain tax and interest rates and all, and then there's a other chatbot which is for, let's say, creative writers or directors and all. Question: the chatbot in which I lower the temperature, which particular scenario is going to be better? Should the lower temperature chatbot be used for bank or poet? Those who say that it is for bank, you guys can raise the hand for low temperature. Okay, Kush says that it's for the bank. Perfect. So this shows a clear-cut answer, and this is absolutely on point. And even I see Rahul, Vipin, and I think Ishika also saying yes, yes, perfect, perfect, perfect. Guys, so you understood. Great. So yes, if you lower the temperature, that means you're skewing up, like only the best answer is going to be present, which is good for very factual information, which is like bank. For creative scenarios like poets and all, you should keep the temperature higher. Very nice. Now, basically, let's jump on to a very powerful concept, which is pre-training. What is this? So the context is that this is the birth of the model. Very beginning, which is like you would have heard about this term pre-training. So before it can even help you, it must understand the world. That is the context. Think of pre-training as a student reading the entire internet to learn how humans communicate. It's not about like facts and all, it's about patterns which it is trying to identify. So for example, the next token prediction scenario, the model's only task is to hide the next word in a sentence and to try to guess its, like let's say, in a different mechanism millions of times. And then it figure out emergent properties from it. So as we scale the data, sometimes some kind of scenarios are gonna come out. The model doesn't just learn grammar, it develops emergent properties. Let's say some sudden change, non-linear jumps in the ability where it starts to understand the logic, basic math, and even world facts. Purely from the statistical structure of language, nothing else. And that is emergent properties, which it is trying to do. And then what it does, it basically at this stage, the model is like you can think of it as identityless. If you ask, who are you? It may answer, who are you? Back to you. Because it's simply following the pattern of a dialogue it saw in a forum. It is like very highly powered, but it is like in an autocomplete scenario, but it is not yet an assistant. So that's the pre-train. So like there is a life cycle of building the large language model. And this is the very first thing, which is pre-training. And at this stage, I'm talking about what is this stage about, how this pre-training is, what exactly it is. So again, the pre-training has three characteristics you can consider. It is identityless. So it's not an assistant. So it's not gonna just give you some answer. It's identityless. You can ask it a question, it may just answer in the same question manner. When it is scaling, it is looking at some emergent properties like some sudden change, some non-linear jumps, where it starts understanding the logic, basic math, some facts, and all of them in a structured statistical scenario. And then again, the only task for it is to hide the next word in a sentence and try to guess it millions of times. That's it. That is basically the pre-training scenario in a large language model stage. Then comes the second thing, which is instruction fine-tuning. This is where the assistant logic sits in the life cycle. This is the place where you give the model its job description. We turn the student into a professional. Think of it like a student was just reading the book, and then now they are now getting into a scenario where they can actually become a professional. To move from a text completer to a helpful assistant is happening in this stage where we use instruction fine tuning IFT. So what happens? We have behavioral alignment. We feed the model thousands of pairs and instruction. Example, summarize this as an ideal answer. This is a like you give a command logic to it. There's a technical shift in how the model processes your input instead of trying to continue your sentence. It learns that prompt is a command which have to be obeyed. Also, some sort of formatting where the model learns some kind of etiquettes around a professional answer related to some complex topics, using bullet points, maintaining a helpful tone. All these things are happening in IFT, instruction fine tuning. So what is happening? We started with a pre-training stage and then we went to an instruction fine tuning stage. Well, to remember it, think of it like you're trying to build an assistant logic to it. Once this is done, then the famous term comes in, which is basically the fine tuning techniques or fine tuning scenario. So you have done instruction fine tuning and finally you are in a fine tuning stage. And this is very important because most of the time, engineers are in this stage and trying to do some things here and there. So in very general world, we have budgets. I cannot spend millions of dollars. I cannot spend, let's say, any amount of money. So we need to choose the intensity level of how much I can do with fine tuning, what kind of training I can do there. So fine tuning is like, if I call a full fine tuning scenario, everything there, it's like a brute force. What we are doing, we update every single parameter in the model. It is very powerful, but it requires massive GPU clusters and it is very expensive. The full fine tuning, which is like a brute force. And that is why new methods evolved, new techniques evolved, and one of the most famous thing which even you guys would have heard about is LoRa or QLoRa. It's very interesting and it's very important. So what is happening? This is like a standard, and this is a standard for most of the startups because that's the way you go about when doing it. So what we do, we freeze the massive base model and only train tiny adapter layers on the top. We do not train all the parameters. We train only tiny layers on the top. It's like adding a specialized, let's say, to give an example, I want to do something with respect to medical niche. So from a general purpose Llama model, I'll just plug in the brain behind, let's say, medical side, and it's like I just do a fine tuning on top of it with LoRa. So it's like it's fast, it's cost effective, and also it ensures that the model's original intelligence is there. Plus at the same time, you are looking at building a niche from that model. There is another thing which is again very interesting, which is RLHF. It's like the final stage of alignment. What we show the model are, let's say, two answers. One which is like a human one, or other which is like an AI one. This trains the model to prefer being safer, more accurate, and less biased over time. Again, this is something which is like a technique which can evolve on a very step-by-step direction for us. Okay, so what we just learned about is a concept which is full fine-tuning, which is a concept which is LoRa, and then the kind of a moral polish on top of these fine-tuning, which is like a final alignment for this final stage, where we show the model two answers, the human one, the AI one, say that what do you prefer? You have to be safer, more accurate, and less biased over time. And this is important to understand how it's being used about. Now, one last thing, which is like, what is the impact of practical scenarios in which biasness comes in the picture? So Like, let's move on from a more technical theory where we understood what is biasness. What is the cost of this biased engineering across the globe? Okay, and I wanted to touch this as one of the slides which is coming out of the technical concept, but this is important when we also touch the concept of ethical AI. And it is being talked about a lot in a lot of places, but when it comes to core implementations, people try to commercialize their models and all. A lot of times this is sidelined or ignored. So I want to give a specific focus on it and explain some practical bias examples so that we are aware about when we are using these models. There is a highly likely scenario that there is a biasness. And if we are aware about it, it's a good thing because then our answers, our thinking process can also be in that direction. So, as engineers, we often think of bias as like a bug, but it is actually a real world problem. When a model inherits the statistical, let's say, prejudices of its training data, it doesn't just give a wrong answer, it creates unequal user experience which can impact someone's health, career, finances, or psychologically. A lot of things can happen. Example, there can be stereotypes which can be created because of some pattern traps. Because LLMs prioritize the most frequent patterns, they often replicate outdated, let's say, societal norms. In one of the cases, a major technical firm had to scrape its AI hiring tool because it learned to downgrade resumes containing the word women. And this is something which is a clear real world example of what it can do. Simply because historically successful candidates in its data set were predominantly men. And it took that. It was not something which is like there was a hate, but it was just a blind mechanism in which you just throw the data and train it. And it creates a stereotype in that direction. The other example of it is a kind of a digital divide or regional disparity. Most foundational models are trained on English centric internet data. It represents dominant Western viewpoints. For example, in India, this creates a massive knowledge gap. For example, think about it, voice models for regional languages, let's say Tamil or Telugu, often sound overly formal or a little outdated because they lack the high quality everyday conversational data needed to understand those local nuances. And this can happen. This is not something which doesn't. The idea is that we know that this can happen. It will improve. Things are going to be much more normal. Things are going to be much more better. We are still improving. Like there are a lot of good models which have come out. Like Chatterbox is doing pretty good in Hindi, in other languages. It's like things are going to improve, but the important part is we know the scenarios where there are gaps and how those are coming up. The other thing is some kind of economic misalignment also happens with it. Models trained on Western data often use Western proxies for success. A medical algorithm once mistakenly prioritized wealthy patients for care simply because it uses previous healthcare spending as a proxy for medical need. It failed to realize that in poorer communities, low spending isn't a sign of health, it's a sign of lack of access. That is an economical misalignment which can also happen because of the practical nature of biasness which a data can put in the system. So it's not just about creating some stereotypes, it's not just about some kind of digital divide or scenario where because of less data something can come up. It can also be related to economic misalignment where it took some other direction to just get to its goal in terms of pattern understanding. And it completely ignored the fact that on the poorer financial side, the lack of access can also be an issue. So this is important to understand, and that's why I mentioned about it, and I thought that I'll let you guys know. But before we jump on to a closure here, I want to ask one last question, which is assume that you are a startup, you are on a limited budget, you want to train a large language model for a very specific task, let's say some kind of medical activity where you're training for robotics. Are you gonna prefer full fine tuning or LoRa? And what is the reason for it? But reason ignored for the time being. Like, after understanding the concept, very simple question. If you're a startup with a limited budget, is full fine tuning better or LoRa is better? Those who say LoRa is better, you guys can raise your hand. Okay, I can see Ishika, I can see Mohak, I can see Alan, Kripa is here, Arpit, and nice. Okay, so you guys, yes, okay. So that means somehow I'm able to make you understand the concept. So that's great. So yes, LoRa is better because that will save a lot of cost for us in this scenario. Now, this basically brings up to the very last section where I'm gonna like give a quick idea around the CBX community, where what we are doing and what we are trying to do here. It's like we are discussing RAG architectures to constitutional AI, putting a lot of things on the channel, and you can join the community, stay ahead on the regular practices which are happening and which from which you can learn on AI through just joining it. And there's a Discord channel where you can get access to AI workshops. There are a lot of master classes which are also going on in offline scenario plus online. But the core idea is that how can we ensure that our full stack engineering activities, or where we are into front end, back end, or we are learning AI, can learn AI faster, and maybe at some point of time, maybe in 10, 15, 20 days, how fast we can have the knowledge of state of the art scenarios. We also host exclusive AI mixers, which are like in Delhi, Bangalore, Jaipur hackathons, where you can actually build these systems with a lot of different concepts and scenarios. So, what you just need to do, scan the code, join the community. Very simple. Again, the goal is to move you from kind of a theory concepts to more of outcome driven, think in a real world direction, become better decision makers. AI is evolving. India is growing at a very fast pace in this domain. There are more than a million opportunities in India at this point of time available. But how can we become better and we build our very powerful models from those? That's important. So this program is built for real results, providing hands-on skills, some kind of mentorship in parallel. So you don't just learn the concepts, you learn how to build a career-defining portfolio which contain vision language models, large language models, and different concepts which are state of the art, and projects that can prove the expertise in your industry. But yeah, thanks a lot for your time today. Thank you very much, guys. And I think we'll connect back again for the next webinar and it'll be interesting. Thank you very much. Good day, guys. Bye bye.